So keep the questions relevant to the questions that we're doing. If you have any other questions in general, as I said, we could discuss them at the end of the class. A farmer sells eggs. The weights in grams of the eggs can be modeled by a normal distribution. Okay, so now we have normal distribution with mean 80.5 and standard deviation 6.6. Eggs are classified as small, medium, or large according to their weight. A small egg weighs less than 76 grams. And 40% of the eggs are classified as medium. Find the percentage of eggs that are classified as small. Okay. Percentage of eggs that are classified as small. So basically, you can just find the probability of having a small egg, right? And then write that probability as a percentage. So you have a normal distribution with mean 80.5. You can write that here. Mean is 80.5. What's the standard deviation? The standard deviation is 6.6. Okay, small eggs are when their weight is less than 76 grams. So let's assume that weight is denoted by X. What's the probability of the weight being less than 76? That is what we're looking for. We have the mean given, we have the standard deviation given. We have to find probability. This is simple normal distribution, right? How does it work? You convert X to Z first of all using the formula. What's the formula? Z equals X minus mu over sigma. You use the formula to convert it to Z form first. So it becomes Z less than 76 minus mu, that's 76 minus 80.5 divided by sigma. Sigma is 6.6. What do you get from this? Probability of Z less than 76 minus 80.5 divided by 6.6. Remember, your Z values have to be correct to 3 decimal places because that's the level of accuracy of Z values in the normal distribution table. So this turns out to be Z less than minus 0.6818. Rounding off gives you minus 0.682. Now this is not the standard form. You can't use the normal distribution table in this case directly, right? For using the normal distribution table, you need this form, Z less than a positive number. This is not that form. So what do we do now? We think of the normal distribution curve and convert it to this form to be able to use the table first. Okay, so how do we do that? Let's think of the normal distribution curve. You draw a rough sketch like this. If it's a Z distribution, you have 0 in the middle, negative value is going to be on the left side. Let's say that's here, minus 0.682. What's the area that we're looking for? We're looking for the area to the left of this value. So this is the area that we're looking for. Okay, what we can do for this is we can flip this first. We can say that area is the same as the area to the right of 0.682. That's the same as this area. So we could convert it to this form first. We could say this is the same as probability of Z greater than 0.682. But this is still not the standard form. Standard form is Z less than a positive number. So now we can say, since the total area is 1, we can subtract from 1 the area to the left of 0.682. And that gives us 1 minus probability of Z less than 0.682, 1 minus phi of 0.682. Now you can use the formula sheet because this is the standard form. Now just look at the formula sheet, look at the normal distribution table and see what is the probability value corresponding to 0.682. And that is what you're going to input here. 0.682, that's the Z value. Now let me just copy the normal distribution table here. S1 table should be here. Okay, so what was the Z value? The Z value that we had here was 0.682. Just look at the formula, look at the normal distribution and see what value you have corresponding to that. Z value is 0.682. 0.6 is here. and then 8 is here. That's 0.7517. And then the last decimal place is 2. You have to add 7 at the end. What does that give you? 0.7524. Okay? 0.7524. 0.7524. Subtract that from 1 and you will get your result. You can see what that turns out to be. Okay, Mosem, can you please remind me on the WhatsApp group as well? Leave a message there and I'll do that. 0.2476. Okay, that's the result that we get in the first part. Pretty straightforward, simple normal distribution, right? So if you have understood, if you know the concept, this is these are simple 3 marks. Now it says find the least possible. Okay, no, I'm sorry, this is not the final result yet because they were asking for percentage of x. What's the percentage of x that is classified as small? Write this as a percentage now. 24.76%. Right? That's the percentage that we were looking for. Okay. All right. Now it says find the least possible weight of an egg classified as large. Okay. Now, how do we think about this? So there are 3 categories. There is small, then there's medium, and then we have large. How many eggs, what percentage of eggs are small? 24.76%. And then the question tells you 40% of the eggs are classified as medium. So in the middle, you have 40%. This part is 40%. What is remaining for large? What percentage is large? 100% minus both of these. What does that give you? 35.24%. This is the percentage of large eggs. Okay. Now, it says find the least possible weight of an egg for it to be classified as large. Now, let's say the least possible weight that we're talking about, let's say x, probability of x greater than this value, let's call this W. Probability of x being, or something to confuse you, let's call this A. Least possible weight, we're saying this is A. Okay. Probability of x greater than A. If A represents the least possible weight for it being a large egg, what's that probability? That probability is this, 35.24%. In decimals, what would that be? That would be 0.3524. We are looking for this value A. That is what we're looking for. We want to find this value A somewhere. Now, what kind of normal distribution is this? This is inverse normal, right? You have probability given, you have some missing information in the data that you have to find out. You have to find the value of A. Now, how does this work? You've got the mean of the data given. The mean of the data was 80.5. You have the standard deviation given as well. That's 6.6. You need to find the value of A. Now, how does inverse normal work? We just apply the standard inverse normal method on this. If x is greater than A, the probability of that is 0.3524. We can say, okay, probability of z being greater than some value, that is equal to 0.3524. We need to find the z value first of all. But how do you find the z value? Remember the process. You need to figure out, is the z value positive first or negative? Because remember, in order to read the table, you need this form. This is the form that you need to be able to read the table. You want to convert it to z less than positive form. For that, you have to figure out whether the z value here corresponding to A is positive or negative. How do you figure that out? It's greater than sign. So basically, you say the area to the right side, area to the right of the z value Is that greater or less? Is that more than 0.5 or less than 0.5? This is less than 0.5. This is smaller area. Smaller than 0.5. What does that mean? If the normal distribution curve looked like this, since the total area under the graph is 1, where can we place Z here? Is Z going to be placed on the right side or on the left side? The area to the right has to be smaller. Now, if Z was here, the area to the right would be bigger. The area to the left would be smaller. And if A was on the positive side, in that case, the area to the right would be smaller. So that means that Z is supposed to be a positive number. So this is a positive number. This is the first thing you have to figure out. This is positive. Okay, Z is positive. Now, once you figure out that Z is positive, now you need to convert it to standard form, Z less than a positive number. So now that you are given that this area on the right side, how much is that? That's 0.3524. That is the same thing as saying the area to the left of this value, that will be 1 minus that. What's that? 1 minus 0.3524. That is 0.6476. So we could write the same thing as this. We could say probability of Z less than that positive value of Z, that is 0.6476. And now this is the standard form. We can go to the table and find the Z value corresponding to this probability, 0.6476. Okay, now remember that value. Probability was 0.6476. Okay, now let's look for 0.6476 here. 6476. Okay, this is the number that we have smaller than that, right? 6476 exactly is not available, so we use the smaller number from that. 0.6443. What's the corresponding Z value that we're getting here? 0.37. Okay, so Z value is supposed to be 0.37. Now, what about the third decimal place? Let's figure that out. So we have 0.6443 in the table. How much more do we need to add to that? 0.6443. How much more do we need to add? 76 minus 43. What's that? That's 33. 33 still needs to be added. Now go to the right side and find 33 here. Do you have 33? Well, you don't. But is 33 closer to 34 or 30? It's closer to 34. Use 34. The corresponding third decimal place turns out to be 9. So you have 0.379. That's the value of Z that you get from this. Is that okay? .379. Let's go back. So that means the Z value is 0.379. Now you use the formula Z equals X minus mu over sigma and input values in that. Now Z is supposed to be positive, right? So you need to be careful. If you had figured out earlier that Z was negative, you would have to input negative value of Z here, but Z is supposed to be positive. So Z value is 0.379 now. Just input this in the formula. 0.379, that equals X, which is A. In case of X, you put A. Minus mu. Mu is 80.5 divided by sigma. And that is going to give you the value of A. You can see what that turns out to be. What's the value of A that we get? 6.6 into 0.379 plus 80.5, and that's giving me 83.0014. That's just 83.0. That's the value of A that we were looking for. No problems? Okay, let's move on to the next one now. Question number 6. It says, the mass of grapes sold per day by a large shop can be modeled by a normal distribution. With mean 28 kg on 10% of the days, less than 16 kg of grapes are sold. Find the standard deviation of the mass of grapes sold per day. Okay. So we have normal distribution. We are given the mean. Mean is 28. On 10% of the days, less than 16 kg of grapes are sold. Okay. So if we call the mass of grapes sold per day X, we are given that the probability of X being less than 16 is equal to 10%, which is 0.1. All right. We need to find the standard deviation and see what that is. This is an inverse normal problem. Let's see what the value of standard deviation turns out to be. Why? Because we've got mean given, we've got this value of X given, we've got the probability given, and we've got something missing in the data. Standard deviation is missing. We need to find that standard deviation. So this is inverse normal. Okay. So let's just use the standard inverse normal process, and that will give you the value for standard deviation. Let's try this. Yes, Mariam, you're right. That's what it means. That dash on top means not A, right? That A is not included. Outside A, basically A complement, if you remember that from O levels. Okay, this is what we're given. Now, how do you find this? How do you find the value of standard deviation? Let's first write this in terms of Z. So it becomes Z less than some number, probability of this equals 0.1. Now, the first thing we have to do is we've got to figure out whether Z is positive or negative. That's the first thing we need to figure out, whether Z is positive or negative. How do you figure that out? Using the normal distribution curve. This is what the curve looks like. Okay, this is what the curve looks like. We've got 0 in the middle. It's a Z distribution. We want the area to the left of Z to be smaller than 0.1, smaller than 0.5. Area to the left of the Z value is smaller than 0.5. Where do we place Z? Do we place Z on the negative side or on the positive side? If we place Z on the negative side, the area to the left of Z would be smaller, and that's what we want. So that means Z is supposed to be a negative value. So that's what we figured out. Z is supposed to be a negative value. Okay. Now, if Z is a negative value, we are given that this area to the left of Z, this is 0.1. Now, this is not the standard form. You can't use the table for this. You have to first flip it. When you flip it, you say, okay, the corresponding area on the right side, this should also be 0.1. Area to the right of this positive value, this should also be 0.1. But again, that's not standard form. We want Z less than a positive number, less than a positive number. So if this is 0.1, we can say the area to the left of this positive value of Z, that is 0.9. And we could actually write this probability as probability of Z less than the positive Z value, that is equal to 0.9. We could write it in this form. And now, from the table, we can figure out what this positive value of Z is. Okay, the probability is 0.9. Find the corresponding Z value corresponding to this probability. Let's see what we get from the table when probability is 0.9. Okay, so this was the table. Probability was 0.9. If you notice at the end of the table, you have this value given directly as well. So there are some common values that they actually list down at the end of the table as well. So these are probabilities 0.75, 0.9, 0.95, and so on. If you get one of these, you can actually just use this value directly. You can find from the table as well. From the table as well, you get the same value. When probability is 0.9, you can check that from the table. The corresponding z value will turn out to be 1.282. Okay. They have written this value separately here as well. You can just use this. Okay. That's 1.282 z value. Let's just use that here. So corresponding z value turns out to be 1.282. Now this is the positive z value. Actual z was negative. So we say the actual z value therefore is minus 1.282. That's the actual z value. Now use the formula z equals x minus p over sigma. And that will give you the value for sigma. Minus 1.282. That equals x, which is 16, minus mean, which is 28, divided by sigma. And that will give you the standard deviation. You can see what that turns out to be. What do we get for standard deviation? Okay, can you guys hear me now? All right. So the standard deviation turns out to be 9.36. All right, thank you. Standard deviation is 9.3604. You're saying we could round it off to 9.36 if we want. Okay, so that's the standard deviation. Now it says the mass of grapes sold on any days independent of the mass sold on any other day. 12 days are chosen at random. Find the probability that less than 16 kg of grapes are sold on more than 2 of these 12 days. Now, forget about the days for now. Just think of one day first. What's the probability that less than 16 kg grapes are sold on one day? Do we know that? We know this for one day. On 10% of the days, less than 16 kg of grapes are sold. We are given this probability. If this was not given, we could find this using the normal distribution, right? This was given, that 10% is the probability that on a particular day, less than 16 kg grapes are sold. This probability is 0.1. And now they're saying 12 days are chosen at random. Out of them, what's the probability that less than 16 kg were sold on more than 2 of these 12 days? What kind of distribution is this? This is binomial distribution. We're talking about number of successes. So if we call selling more than 16 kg of grapes in one day a success, we are talking about what's the probability of getting more than 2 successes out of 12. So this is binomial. This is binomial in which this is what we're calling success, selling less than 16 kg grapes. Yeah, so less than 16 kg. That's what we're calling success. What's the value of n? The value of n would be 12. What's the probability of success? We know that is 0.1. If probability of success is 0.1, what about the probability of failure? That will be 0.9. That's a binomial. We want to find the probability of getting more than 2 successes. That means 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's too many probabilities to calculate. We can reverse this. We can say, let's calculate it like this. 1 minus probability of getting less than or equal to 2 successes. And that will be 1 minus probability of x equals 0 and x equals 1 and x equals 2. Okay. And now we use the binomial formula. What's the binomial formula? NCR p raised to power r q raised to power n minus r. Just input values in that formula and you get the result. 1 minus n was 12. 12c0 into p, which is 0.1, raised to power 0 into 0.9 raised to power 12 minus 12c1 into 0.1 raised to power 1 into 0.9 raised to power 11 minus 12C2 into 0.1 squared into 0.9 raised to power 10. You'll calculate this and see what that turns out to be. Again, it's better to do it step by step because that will give you more partial marks in case your final answer is incorrect. If it's correct, it's all right, but how would you know in the exam? 0.111. Okay, so that's what you're saying. The final result turns out to be 0.111. Is that okay? All right, let's look at the next part now. In the next part, it says, in the random sample of 365 days. So now we're talking about 365 days. On how many days would you expect the mass of grapes sold to be within 1.3 standard deviations of the mean? Okay, so now we've got 365 days. On how many days would you expect it to be within 1.3 standard deviations? Now, one way to do it is like this. If you know what the Z value means, Z value basically tells you the number of standard deviations something is away from the mean. So if a Z value is 1, that means that X value is 1 standard deviation above the mean. If a Z value is minus 1.5, that means Z value, that X value is, that data point is 1.5 standard deviations below the mean. So basically, you could write it directly like this. You could say within 1.3 standard deviations, this could be written as probability of Z between minus 1.3 and plus 1.3. That is what you want to calculate. Now, if you understand it, that's great. You could use it directly. If not, you could convert it. So we're talking about 1 day for now, right? Forget about 365 days. We'll deal with that at the end. Talk about 1 day first. On 1 day, what's the probability of the number of grapes sold being between within 1.3 standard deviations? If you understand the concept of Z value, you could write it directly like this. If not, the other possibility would be you'll start from X. Within 1.3 standard deviation means from the mean, you could go plus 1.3 standard deviations. That will be mean plus 1.3 standard deviations. Or from the mean, you could go minus 1.3 standard deviations. So you want to be between these two numbers. Okay. Now you could calculate that and see what that turns out to be. You want to be between mean minus 1.3 standard deviations and mean plus 1.3 standard deviation. What's the mean? Mean is 28 kilograms. Okay. Minus 1.3 standard deviations. What's the standard deviation? If calculated that in the first part, in the previous part, 1.3 into 9.36. And on the other side, you'll have mean, which is 28, plus 1.3 into 9.36. See what that gives you on both sides. 28 minus 1.3 into 1 into 9.36. That is 15.832. And on the other side, 28 plus 1.3 into 9.36. That is 40.168. Yes, we are multiplying 1.3 with the standard deviation, which was 9.36. Why? Because it says within 1.3 standard deviations. That means from the mean, you could go below 1.3 standard deviations and above 1.3 standard deviation. 1.3 standard deviations means 1.3 times the standard deviation, right? So 1.3 into standard deviation. That's exactly what we're doing here, okay? So what 9.36 is the standard deviation value. This is what we get. And now we could convert it to Z. Let's try that. Z then should be between 15.832 minus the mean, which was 28, divided by standard deviation, which was 9.36. And then on the other side as well, 40.168 minus 28 divided by 9.36. You're basically reversing all of this. You basically earlier added 28 and multiplied by 9.36. Now you're subtracting 28 and dividing by 9.36. And you see what you get from this at the end. This will turn out to be, you can verify this, 15.832 minus 28 divided by 9.36. And that gives you minus 1.3. And on the other side, you get plus 1.3. So you could actually skip all of this if you understand the meaning of Z value. Z value means the number of standard deviations you are above or below the mean. So if they're saying within 1.3 standard deviations, you could directly write this using that. Okay? And you would not have to do all of this in that case. And now you just need to find this probability. How do you do that? That's the question now, because you've got a two-sided interval now. Okay, so how do you think about this? Let's make a normal distribution table, normal distribution curve. This is what the curve looks like. You've got 0 in the middle, 1.3 on one side, minus 1.3 on the other side. Since the curve is symmetric, you've got both those points at the same distance from the mean, and this is what we are looking for. This is what we want to find out. Now, how can we find this area? One way, so now there could be multiple ways of figuring out this area, right? One possibility would be that you find half of this area, right? So you find this area. Since the curve is symmetric, right? We could use the symmetry of the curve and find this area first. Can you find that? Just find the area to the left of 1.3. Probability of Z less than 1.3. That will give you all of this region. This is something that you will get from the table directly. Subtract from that 0.5. And that will give you this part that I've shaded with lines. Make sense? Probability of Z less than 1.3. That will be all of this to the left of 1.3, right? Subtract from that 0.5, this region. And that will leave you with that line shaded part that I've shown there. Once you have that one part, you can just multiply that by 2 to get the total probability. Since the curve is symmetric, the area on the left side is also going to be the same as that. You can multiply this whole number by 2. And that will give you the total region. This is one way to think about this. You could do it another way as well, and that's perfectly okay. There are multiple ways of doing this. But this is, I think, the quickest in this particular scenario because of the symmetry of the curve. We can find this from the table, Z less than 1.3. Okay, so when the value of Z is 1.3, what are we getting? 0.9032. That's the probability that we've got, 0.9032. .9032 minus 0.5. This part inside the bracket is going to give you this part. And then multiply that by 2, you'll get the result. What do we get? 0.9032 minus 0.5 multiplied by 2, and that's 0.8064. That's the probability that on one day, the number of grapes sold is within 1.3 standard deviations of the mean. What would be the expected number out of 365 days when this condition is satisfied? You just multiply 365 with this number and see what that gives you. 294.336. Now, since we're talking about number of days, that has to be an integer. So you round it off to 294 and you say that's your final result. The expected number out of 365 when this condition would be met is 294. And that's your final result. Try this one out. Question number 5. It says the lengths in centimeters of the leaves of a particular type are modeled by this distribution. N 5.2 and 1.5 square. Remember in this notation, what are these values? 5.2 is the mean and 1.5 squared is variance. Okay, variance is denoted by sigma square. Find the probability that a randomly chosen leaf of this type has length less than 6 centimeters. Now this is simple normal distribution, right? If we are saying lengths are denoted by x, we want to find the probability that x is less than 6. It's normal distribution. We convert it to z first of all. It becomes z less than 6 minus mu, which is 5.2 divided by sigma. Sigma in this case is 1.5. So we divide by that and see what that gives us. Probability of z less than 0.8 divided by 1.5, and that's giving me 0.533 to 3 decimal places because the values of z in the table are correct to 3 decimal places. Now, if it's the standard form already, z less than a positive number, we can find this value directly from the table and that will give us the result. Okay, let's do that. 0.533. Let's find this value in the table. All right, 0.533. What do we get for this? 0.7019. Then we have to add 10 at the end. That becomes 0.7029. Okay. Let's write that here. 0.7029. That's the probability that we were looking for in the first part here. Okay, you can just leave it like this. That's your final answer. Okay. Now it says the lengths of the leaves of another type are also modeled by a normal distribution. A scientist measures the lengths of a random sample of 500 leaves of this type and finds that 46 are less than 3 centimeters and 95 are more than 3 centimeters long. Find estimates for the mean and standard deviation of the lengths of leaves of this type. Now the mean and standard deviation are missing, and we've got some information about probability. This is inverse normal. Right? What information are we given? When they took a sample of 500 leaves, they found that 46 are less than 3 centimeters long. So we can say the probability of a leaf being less than 3 centimeters long is what? 46 out of 500. Right? The relative frequency concept that we've done in O-levels as well. Probability can also be thought of as relative frequency. So 46 are the favorable outcomes divided by the total number of outcomes, 500. We say the probability of x being less than 3 is equal to this. 46.500, you can see what that is. That's 0.092. Similarly, they're saying the probability that a leaf is more than 8 centimeters long. That means probability of x being greater than 8, that is equal to 95 over 500. That gives us probability of x being greater than 8. That's 95 over 500. That's 0.19. And now this is inverse normal. You convert it, you write this in terms of z first of all. Find the values of z and then put them in the equation z equals x minus mu or sigma. You get two equations, simultaneous equations, solve them simultaneously, and you would get the result. So how do we apply by inverse normal distribution? We say, let's write this in terms of z. X less than 3 is basically 0.092, the probability of that. we can say z less than some value, this probability will be 0.092. And now we need to figure out whether this z value is positive or negative. How do you do that? You think of the normal distribution curve. This is what the curve looks like, roughly. Since it's a z distribution, we have 0 in the middle. Is z going to be placed on the negative side or the positive side? The area to the left of z is smaller than 0. So how do you think about this? Less than means we are looking at the left side. The area to the left is supposed to be smaller than 0.5. How can the area to the left be smaller? If we place z here, the area to the left would be larger. We don't want that. If we place z here on the left side, on the negative side, that is when the area to the left side would be smaller. That means z is supposed to be a negative number. So z is a negative number. That's what we understand from this. Z is supposed to be negative. And we're given that this area is 0.092. Now, this is not standard form then. How do you convert it to standard form? You can see this is the same thing as saying the area to the right of this positive z value. This is 0.092. And then if that is 0.092, what about the area to the left of this positive z value? This will be 1 minus 0.092. If this area is also 0.092, the area to the left is 1 minus 0.092. What does that give us? 0.908. So we could write that as probability of z less than the positive value of z, that equals 0.908. Now this is the standard form. We can go and look for the value of z in the table now. The probability is supposed to be 0.908. Let's find the corresponding z value to this probability. 0.908, where is that? Let's find that probability, 0.908. Let's write that inside, 0.908. Okay, this is the number that I have here in the table. That's slightly smaller than that. The immediately smaller number than 908. 908 means 9080. Okay. Now, what value do I get corresponding to this for z? 1.32. But that's the value of z corresponding to 0.9066. What's the difference between them? 14. So we need to add 14 more to it. We go to the right side. Do we have 14 here? Yes, this is 14. We take 9 from here, and the value of z therefore becomes 1.329. That's the value of z that we use here, 1.329. Let me go back there. And now we say the positive z value is 1.329, but actual z was supposed to be negative. So we say the actual z value, which was a negative value, that is equal to 1.329. Okay. Now that we know this, now put this in the formula. Z equals x minus mu over sigma. So that's minus, I'm sorry, this is negative. Let's put negative here. Minus 1.329, that equals x. In place of x, we've got 3 here. Minus mu over sigma. This is one equation that we've got. Now, using the same method, we would derive another equation from this. How do we do that? We say probability of z greater than something, that is equal to 0.19. And again, we think of the area to the left or right. In this case, we're looking at the right side because of this greater than sign. The area to the right should be smaller now. If the area to the right is smaller, where is z going to be placed now? Z is going to be placed on the positive side now. because the area to the right is supposed to be smaller. So now Z is going to be placed on the positive side. So Z is now supposed to be positive. And we're given that the area to the right of Z, that's this area is 0.19. Now this is not standard form as well. If the area to the right of Z is 0.19, what about the area to the left of the Z value? We can say probability of Z less than this positive value of Z, that is 1 minus 0.19. This region is 0.81. We have 0.81 here. And now we can go to the table, find this value of Z from that corresponding to 0.81. Probability is 0.81 now. So 8100, let's look for that value. The immediately smaller value from than that is this 0.8078. The corresponding Z value that I'm getting from this is 0.87. And that value is corresponding to 8078. Let's find the difference, 22. Now we go to the right and find 22 here. This is 22. And that gives us 8 as the third decimal place. So 878, that's the Z value that we're getting from this, 0.878. Let's write that here. The positive Z value turns out to be 0.878. And the actual Z is also supposed to be positive. So we say Z is 0.878 now. Now let's input this in the formula as well. 0.878, that's Z equals X, which is 8 here, minus mu over sigma. You've got two equations. You solve these two equations simultaneously, and that is going to give you the result. Okay. Now, how do you solve them simultaneously? It becomes minus 1.329 sigma equals 3 minus mu, and mu is equal to 3 plus 1.329 sigma. From the other equation, we get 0.878 sigma equal to 8 minus mu. Mu equals 8 minus 0.878 sigma. Now we equate both of them, and that gives us 3 plus 1.329 sigma equal to 8 minus 0.878 sigma. And that's going to give us the value for sigma. Let's see what that turns out to be. 5 divided by 8 minus 3 is 5, right? 8 divided by 1.329 plus 0.878. And that's giving me sigma equal to 2.2655. That's the value of sigma that I'm getting. Now we put this value of sigma back in the mu equation. We can put that here or here in any of them. What's the value of mu that we get from this? Mu equals 3 plus 1.329 multiplied by 2.2655. And that should give us the value for mu as well. This multiplied by 1.329 plus 3, and that's 6.011. Mu is equal to 6.01. That's what we were looking for. We've got the value of mu and standard deviation, which is 2.27 if you want to round it off. That's what we get. Okay, we found the values of mu and sigma. That's a standard inverse normal problem. Now it took some time, but there wasn't any complication as such. As long as you understand inverse normal well, that's all that you have to do here. Now it says in a random sample of 2,000 leaves of this second type, how many would the scientist expect to find with lengths more than one standard deviation from the mean? More than one standard deviation from the mean. Now remember, when they talk about number of standard deviations away from the mean or within the mean, we can think of this in terms of Z directly. So rather than thinking about variable X, it's easier to think of Z directly because we know Z is a distribution for which the mean is equal to 0 and standard deviation is 1, right? So if the lengths have to be more than one standard deviation from the mean, let's think about this. Mean is in the middle. For a Z distribution, mean is 0. You want to be more than one standard deviation away from the mean. On the left side, you would have -1. On the right side, you have 1. This is one standard deviation away on both sides. You want to be more than one standard deviation away. That means you either want to be in this region or you want to be in this region, right? In the middle, you've got 0. This is 0, which is actually the mean. One standard deviation for Z is 1 unit. If you want to be more than one standard deviation away from the mean, what that means is Z should either be less than -1 or it should be greater than 1. These are the two possibilities that you've got. This is the probability of one leaf being one leaf having a length that is more than one standard deviation away from the mean. Then once we find the probability for one, we can just multiply that by 2000 to find the expected number. But for now, let's find the probability of one leaf satisfying that criteria. Okay, so more than one standard deviation away from the mean, what does that mean? It's either less than -1 or greater than 1. Z less than -1 or Z greater than 1. Now, if you think about it, this is what the normal distribution looks like, roughly. For Z distribution, you have 0 in the middle. If you have -1 here and you have +1 here, what you're looking for is this region and this region. Now, since the curve is symmetric, these two regions are both going to be the same. We can just find one of these and just multiply that by 2. Okay. So which one do we find? Let's find the right one. That's easier. Z greater than 1, we could say that's the same thing as saying probability of, in fact, we could say 1 minus probability of Z less than 1, right? So find the area to the left of 1, subtract that from 1, and that will give you this region. And now it's standard form. You can go to the table, find this probability and see what that turns out to be. Z less than 1. So corresponding to a Z value of 1, what's the probability that we get? It's 0.8413. 0.8413. What's the result that we get from this? 1 minus 0.8413. This is 0.1587. If this region is 0.1587, this yellow region, that means the other one is also going to be 0.1587. So what's the total probability? This one would also be 0.1587, right? Because the curve is symmetric. They're both supposed to be the same. So the total probability turns out to be 2 times 0.1587, or you could say 0.1587 plus 1.87. That gives it the same thing. The probability turns out to be 0.3174. So for one leaf to satisfy the criteria, the probability is 0.3174. Now, if you had 2,000 leaves, how many of them would you expect to satisfy this criteria? Just multiply this number by 2,000. 2,000 into 0.3174. What do we get from that? 634.8. But since we're talking about number of leaves, that has to be an integer. We can't write a decimal here. Let's round it off, and it becomes 635 because we're talking about number of leaves. Right? They're saying how many leaves would the scientist expect to find with these lengths out of 2,000? So we say 635, and that's our final answer. Let's look at the next one now. Question number 4. It says, a mathematical puzzle is given to a large number of students, the times taken to complete the puzzle are normally distributed. So now we've got normal distribution. Mean is 14.6 and the standard deviation is 5.2. Let's call time X. In a random sample of 250 of the students, how many would you expect to have taken more than 20 minutes to complete the puzzle? So first of all, let's find the probability of somebody taking more than 20 minutes to complete the puzzle. And then we'll talk about what happens if you have 250 students. So let's start with one student. For one student, what's the probability that he or she takes more than 20 minutes? So the probability that we're looking for is probability of X greater than 20. Right? If times are represented by the letter X, we want the probability that X is greater than 20. Now, how do you find that? Convert this to Z first of all. So it becomes Z greater than 20 minus the mean. Mean is 14.6 divided by the standard deviation, which is 5.2. And that's going to give you this value in terms of Z. Z is greater than what? 1.038. Thank you. 1.038 to 3 decimal places. And now we need to think of the normal distribution curve, convert it to the standard form, Z less than a positive number. That's the standard form that we've got. We need to convert it to that form. How do we do that? This is what the normal distribution curve looks like. In the middle, we've got 0 for the Z distribution. It's a positive number. So let's say it's here, 1.038. We are looking for the area to the right of this. We can't find this area from the table directly. What we can do is we can find the area to the left of this, subtract that from 1, and that will give us this probability. So this could be written as 1 minus probability of Z less than 1.038. And now this is the standard form. We can look for the probability value corresponding to the Z value and just input that here. Let's see what that turns out to be. 1 minus Z, probability of Z less than 1.038. 1.038. Let's keep that in mind. Okay, 1.038. 1.038. All right, so what do we get from this? 0.8485. And then we want 8 on the side. That's 19. Add 19 at the end. Now you can put this on your calculator like this. On your calculator, put 8485 in case you are afraid that you would do a careless error. On your calculator, you can do something like this: 8485 plus 19. Your calculator will give you some value that will be 8504, and then just put a decimal in the beginning. So that's 0.8504 that you get from this. Okay, 0.8504. 0.8504. And now 1 minus this, what do we get? 0.1496. That's the probability of one person taking more than 20 minutes. Now, out of a sample of 250 students, how many would you expect to have taken more than 20 minutes? For one person, this is the probability. If you are looking for the expected number of people here, you just multiply this by 250. 250 into 0.1496 and see what that turns out to be. 250 into 0.1496, that's giving us 37.4. Okay, this is what we get. However, remember, we're talking about number of students. Number of students cannot be decimals, right? So expected number of students that we write at the end, it has to be an integer. So we have to round it off to an integer. What does 37.4 round off to? It rounds off to 37. So we should write 37 here. That's the expected number that we have out of 250 that's expected to take more than 20 minutes to complete the puzzle. All right, that's what we were looking for. Let's move on. That was part A. Part B says, all the students are given a second puzzle to complete. Their times in minutes are normally distributed with mean, mu, and standard deviation, sigma. So now we've got a second puzzle. Mean is mu, standard deviation is sigma. Both of them are unknown. None of you can hear me?
We can hear you, sir.
Okay. All right, so maybe it's a problem at your end. AT, I'm not sure who you are. Yes, maybe try leaving the meeting and joining again. That works mostly. Try rejoining. Hopefully that will work. Or in fact, if you can't hear me, how will you hear me saying this? Let me just write that in the chat box. What's that? Okay, all right. Yeah, so it works for you now. Good. Okay, so it says it's found that 20% of the students have times less than 14.5 minutes and 67% of the students have times greater than 18.5 minutes. Find the value of mu and the value of sigma. Okay, so that's again a relatively standard inverse normal problem. It says 20% students have times less than 14.5. That means the probability of the time being less than 14.5, what's that? That is 20%. That's 0.2. And then 67% students have times greater than 18.5. So probability of somebody having a time of greater than 18.5, that is equal to 0.67. Now we just need to find two equations in terms of mu and sigma and solve them simultaneously. Now, how do you do this? You first write it in terms of z. So you would say if x is less than 14.5, that means z less than some value that is equal to 0.2. We need to figure out, first of all, whether z is positive or negative. How do you do that? You need to think of this normal distribution curve. Less than means you're going to be looking at the left side. Area to the left of this z value is supposed to be smaller. It's smaller than 0.5. So the area to the left should be smaller. So what do we understand from that? Is z going to be positive or negative? If we place that on the negative side, then the area to the left would be smaller, and that's what we want. So z value is supposed to be negative. That's what we understand from this. Okay, so the z value at the end is supposed to be negative. All right. Now, since this is negative, we are given that the area to the left of the z value, how much is that? That is 0.2. This area is 0.2. Okay. Now, if this area is 0.2, this is not the standard form. We have to convert it to standard form. So first of all, what we do is we flip this to make it positive, first of all. So if that area is 0.2, we say the area to the right of this positive value of z, that is also 0.2. And if this area is 0.2, the area to the left of this positive value, how much would that be? That will be 0.8. So you convert that probability to this form. You say probability of z less than the positive value of z, that is supposed to be 0.8. And now using this, we find the z value from the table and then put a negative sign with that because the actual z value is supposed to be positive, supposed to be negative. All right, so now we've converted it to standard form. Let's go to the table, find the z value corresponding to this probability value. So the probability value is 0.8. Let's look for 0.8. Probability is 0.8000. Where is 0.8? Okay, so we are finding 0.7995 here. That's what we've got here. Corresponding to that, we've got 0.8 and 4. So the z value is 0.84. That's the value that we're getting corresponding to 0.995. How much do we still need to add to it? 5. Let's go to the right. This is where we find 5. So the third decimal place, therefore, is supposed to be 2. So the z value is 0.842. All right. Let's go back here. What we understand from that is the positive z value is 0.842. Okay, I'm sorry. .842. Yeah, that's correct. That's what we wrote there. Okay, so positive z value is 0.842. So what's the actual z value? Since it was supposed to be negative, 0.842 is the value that we found from the table, but z was actually supposed to be negative. So z is basically minus 0.842. Now let's input this in the formula. Z equals x minus mu over sigma. What do we get from that? Minus 0.842 equals x. In place of x, we put 14.5 minus mu over sigma. This is one equation that we've got in terms of mu and sigma. Now we repeat this process for that second piece of information. We say, okay, let's write this in terms of z. First of all, z less than some value, z greater than some value now, that is equal to 0.67. Okay. Now, again, we need to figure out whether the z value is positive or negative. How do we do that? We can, again, think of the normal distribution curve. This is what the curve looks like. In the middle, we've got 0. We need to figure out whether z is positive or negative. Again, think of the area. The area to the right, greater than means we're looking at the right of the z value. Area to the right of the z value is supposed to be greater. It's supposed to be larger than 0.5. So area to the right should be greater. Where do we place z? If we place z on the left side, the area to the right would be greater. If we placed z on the positive side, the area to the right would be smaller. We want the area to the right to be greater. So z is supposed to be negative in this case as well, because that makes the area to the right bigger, which is 0.67. Now, since that area is 0.67, now if you flip this, this area, remember, is 0.67, the yellow region. But this is not the standard form. We need to convert it to standard form. We flip this for that. When we flip this, that gives us that the area to the left of the positive z value, this area, that is also 0.67. So we basically convert that probability to this form. We say z less than the positive value of z, that gives us 0.67. And now we need to go to the table, figure out the z value corresponding to probability of 0.67 and see what that gives you. Okay, when probability is 0.67, let's see what the z value is. 6700. Okay, 6700. Where is that? Okay, we've got this exact number here. That's 0.44. 0.44. Okay. So that means the positive z value that we found from the table is 0.44, but actually z was supposed to be negative. We figured that out here. Z was supposed to be a negative value. So what we do for that is we say the actual z value is supposed to be minus 0.44. And now we input this in the formula. That gives us minus 0.44. That equals 18.5. Minus the mean divided by sigma. And that's another equation that we've got now. We can solve these two equations simultaneously, find the values of mu and sigma from this. Now, what I can do is I can make sigma the subject in both of them. That gives me 14.5 minus mu divided by minus 0.842. And from the second equation, I get sigma equal to 18.5 minus mu divided by minus 0.44. Now let's equate these two equations. And that gives us 14.5 minus mu over minus 0.842. That equals 18.5 minus mu over minus 0.44. Now we need to solve this equation to figure out the value of mu. Okay, now how do we do that? Let's multiply 0.44 into 14.5. That's minus 6.38 plus 0.44 times mu. So I've multiplied this on the left side. Similarly, multiply this on the right and see what that gives you. 18.5 into 0.842. That's giving me minus 15.577 plus 0.842 times mu. And now we can find the value of mu from this, take this term to the right, this to the left, and see what the mean turns out to be. (15.577) minus 6.38 divided by 0.842 minus 0.44. And that is giving me 22.878. Mean turns out to be 22.878. And that's what we were looking for. We found the mean. Now, the second thing that we want to find is the standard deviation. Put this back in the other equation. And that will give you the standard deviation. Sigma equals 14.5 minus the mean, which is 22.878 divided by minus 0.842. And you'll get a standard deviation value from this. Now, just a tip, standard deviation can never be negative. If you're getting a negative standard deviation value, that means you're doing something wrong. And you might need to recheck the working. Mean can be negative, but standard deviation can never be negative. 14.5 minus 22.878 divided by minus 0.842, and that's giving me 9.95, and that's the standard deviation that we were looking for. Okay, so we find the standard deviation and the mean. Since 7. Okay, these are the two questions that we want to do from this paper. June 22, paper 5, variant 3. Let's do two questions for this, questions 5 and 7. Let's start with this one. It says, Farmer Jones grows apples. The weights in grams of the apples grown this year are normally distributed with mean 170 and standard deviation 25. So we have the mean given and we've got the standard deviation given. Apples that weigh between 142 grams and 205 grams are sold to a supermarket. Find the probability that a randomly chosen apple grown by Farmer Jones is sold to the supermarket. Now, an apple is going to be sold if it weighs between these two numbers, 142 grams and 205 grams. So we want to find the probability that the weight, if we denote that by X, that's between 142 and 205. This is the probability that you want to find out. Now, how do you do this? You convert it to Z first of all. This is simple normal distribution. Apply the Z formula on this. X minus mu over sigma. That means Z is between 142 minus mu. Mu is 170 divided by the standard deviation, which is 25. And 205 minus 170 divided by 25. What do we get for Z here? We get Z between minus 28 divided by 25, and that's minus 1.12, and 35 divided by 25, that is 1.4. So Z is between these two values. We have to find this probability. how do we do that? Let's think of the normal distribution curve, how it's going to look like. This is what the normal distribution curve looks like, roughly. So you would draw a rough curve like this. And then you have 0 exactly in the middle. That's the mean of the Z distribution. 1.4 is going to be on the right side, and minus 1.12 is going to be on the left side. What we are looking for is the area between these two numbers. This is the area that we want to find. Okay. Now, how do you find this shaded region? It's an interval. It's a two-sided interval. One of those values is negative and the other is positive. Now, this is a standard case that you should learn when you do normal distribution. So it should be nothing new for you. All you have to do is find the total area to the left of 1.4. So you could say it's the same thing as saying probability of Z less than 1.4. That's all of this region. But the problem with that is it will also consider this region. We don't want that region, right? We only want the middle part. So from this total, we subtract the region to the left of minus 1.2. So probability of Z less than minus 1.12, we subtract this probability from that earlier probability. Now, this is something that we can find from the table directly. Z less than 1.4, we can figure out this number from the table. Let's actually do that. Z less than 1.4, that's standard form, right? That's here, 1.4, that's 0.9192. This number is 0.9192. The problem is this other number. This is not standard form. Now we have to think of this again. Z less than minus 1.12. What does that mean? Let's focus on this part now. Again, you can think of another normal distribution curve for this. You don't necessarily have to draw this. You can think of it in your head as well. If you've done enough practice, you may be able to do it directly in your head. Otherwise, it's safer to just draw a normal distribution curve like this. Minus 1.12, that's going to be on the left side here. You want this region on the left side. How do you find that? First of all, you flip it. You say it's the same thing as this region on the right side. The area to the right of 1.12, that will be the same as this. But that's also not going to be standard form. Let me write that like this first. You can say this is the same as Z greater than 1.12. We also can't find that directly. We say, let's find the region to the left of 1.12, subtract that from 1. So it's the same thing as saying 1 minus probability of Z less than 1.12. And this is what we can find. We can say subtract from 0.9192 all of this region. And that is going to give you the result. Okay, now this is in standard form. This is in standard form now, Z less than 1.12. We can go to the table and find the probability corresponding to this number and see what that turns out to be. 1.12. Let's go to the formula sheet. Okay. 1.12. Let me get rid of this first. (1.1) and then 2, we get 0.8686. Let's write that here. 0.8686, 1 minus this. And now we just simplify this whole thing. 0.9192 minus this whole thing. That is going to give us this probability that we're looking for. 0.9192 minus 1 plus 0.8686, and that's giving me 0.7878. That's the probability that a randomly chosen apple is sold to the supermarket in this case. Is that okay to everyone? Any problem with this? Yeah, that's what we were looking for, the probability. No questions? Okay, let's move on. Now it says Farmer Jones sells apples to the supermarket at $0.24 each. He sells apples that weigh more than 205 grams to a local shop at $0.3. Okay, so apples to the supermarket are sold at $0.24. Apples that weigh more than 205 grams, they are sold to a local shop at $0.3 each. And the apples that weigh less than 142 grams, they are not sold. The total number of apples grown by Farmer Jones this year is 20,000. Calculate an estimate for his total income from this year's apples. Now, how do you find this estimate? So we can actually divide this into three parts, basically. We can say one cutoff point is 142 grams, another cutoff point is 205 grams. An apple is either going to be in the region in the middle, in this region, or it's going to be in the region on the right side, where it weighs more than 205 grams, or it's going to be in the region on the left side. Do we know the proportion of apples in each of these regions? We know the proportion for the middle region. We know the probability of an apple falling in the middle region, that's 0.7878. So the probability of being in the middle region is 0.7878. If you want to write this as a percentage, you can say 78.78% of apples fall in this category, in the middle region. Now, what about the ones on the sides? Can we figure those out somehow? Are we given any information about that? No, but have we found any of that in the working that we did in the first part? Okay, so this is what we found. The total region to the left of 1.4, that was 0.9192. And in fact, we also found this eventually. Let's use that instead. Probability of z greater than 1.12. That will be this region. Is that going to help? No, this one, in fact, I'm sorry. Let's focus here. Probability of z being less than minus 1.12. That's this region. That's the probability of an apple weighing less than 142 grams, right? Because the z value minus 1.12, it corresponds to 142 grams. So probability of being less than minus 1.12, what's that? We found that here. 1 minus 0.86. We can actually write this value here as well. So we can use that in the next part then. 1 minus 0.8686, this number was 0.1314. 0.1314. This is the proportion of apples that weighs less than 142 grams. So from this we know 0.1314 is the proportion of apples in this region, 0.1314. And that is 13.14%. Okay. Can you find the remaining apples that fall in this category now? Yes, Faizan, you're right that we actually need the right side. But since we have the left side already, now figuring out the right side is going to be straightforward, right? Because otherwise we haven't found the right side separately earlier. We could actually get that by subtracting this number from 1 directly as well. That could work, yes. But this is another way of doing this, that you find the left-hand side and then subtract these two numbers from 1, okay? And see what the remaining number turns out to be. 1 minus 0.1314 minus 0.7878. And that's giving me 0.0808. But you're right, we could directly just do that. from this 1 minus 0.9192. Because we don't even need this side. The left-hand side is not needed because these apples are not being sold at all, right? So they don't generate any income. So we just ignore those as well. So that's correct. Now, what do you get in this case? You get 8.08% of apples in this region. Now you know that the middle region, they are sold for $0.24. The region on the side, on the right side, they are sold at $0.3. How many apples do we have in this have in each region? Let's find this out. 20,000 multiplied by 0.7878. How many apples is that? 7878 into 20,000. That is 15756 apples. And then do the same thing for this. 0.0808 multiplied by 20,000. That is 1616 apples. And now let's find the total income and see what that would be. For each of these apples in the middle, he's getting $0.24, 15756 multiplied by 0.24 plus 1616 multiplied by 0.3, and that's going to give you the result. You can see what that turns out to be. Okay, this is giving me $4266.24. This is the estimate of the income that he would generate. Now, I've shown a lot of working here because I'm explaining this, but you can also skip some of this, and that's okay. Make sense to everyone? No problems? Now, this was slightly tricky, the second part. Now, let's see what it says here. Farmer Tan also grows apples. The weights in grams of the apples grown this year follow this distribution. 72% of these apples have a weight more than W grams. Find the value of W. Now, this is simple inverse normal distribution. They forgot about the investment? Yeah, so this is so by income they mean the revenue he's generated. So it's not profits, it's basically the revenue, right? So sometimes income is used for revenues as well. It's not necessarily profits, it's just the revenues, okay? All right, now this is inverse normal. It's a normal distribution with mean 182 and standard deviation 20. 72% of these apples have a weight more than W grams. So probability of weight being more than W, that is equal to 0.72. That is what we're given. We need to find the value of W from this. This is simple inverse normal. We say, okay, Z greater than some value, that is equal to 0.72. Now, think of whether Z is going to be positive or negative. Greater means when we look at the right side, the area to the right side, that has to be larger than 0.5. When can the area to the right be larger than 0.5? Where are we going to place Z here? If we place Z on the negative side, the area to the right would be larger. If we place Z on the positive side, the area to the right would be smaller. So where do we place Z? Z will need to be placed on the negative side, therefore. So that means Z is a negative number. This is negative. So that's what we figured out. Z is negative. And all of this region, what's this? This is 0.72. Now, this is not standard form. How do we convert it to standard form? We can flip this and we can say, if the area to the right of Z negative, Z minus is 0.72, the area to the left of this positive value of Z, that is also going to be 0.72. So we can flip this and that gives us probability of Z less than the positive value of Z. That equals 0.72. Now this is standard form. We can go to the table, find the value of Z corresponding to 0.72. Okay, so now probability is 0.72. Let's find that number here. 72 means 7200. This is the immediately smaller number. We say z is 0.58. These are the first two decimals. And the number is 7190. What's the difference? 10. Go on the right side, this is 10. So the third decimal place is supposed to be 3. Z is 0.583 from this. So that means the positive value of z is 0.583, but the actual z was supposed to be negative. So we say z is minus 0.583. And now we need to find the value of w. Let's put this in the formula. Minus 0.583 equals x, which is w in this case, minus mu was 182, divided by standard deviation, which is 20, and that is going to give you the value for w. You can see what that turns out to be. 20 into 0.583, and that's negative. So 182 minus that number, that's giving me 170.34. Significant figures, you're saying that becomes 0.00454. That's the probability that we get. Thank you. Okay, that's the second part. Simple geometric distribution problem. Now let's move on. Question number 5. Okay, let's have a look at this now. It says the lengths of the leaves of a particular type of tree are modeled by a normal distribution. So now this is normal distribution. A scientist measures the length of a random sample of 500 leaves. Length of leaves, that's the variable, we call that x. No, you can write this in standard form as well if you want. You can do that, but generally we write probabilities in decimals, so it's better to write this as a decimal, but standard form is also fine. Okay, but generally they prefer that probabilities are written in decimal form. Okay, so length is measured, and it's found that 42 of them are less than 4 centimeters long. What does that mean? Probability of the length of a particular leaf being less than 4 centimeters long. What's that? 42 out of 500, right? It's the concept of relative frequency. Probability can also be defined as relative frequency, right? So 42 is the favorable outcomes. Number of favorable outcomes, total outcomes are 500. So probability is 42 over 500. And that gives you x less than 4, probability of that equal to 0.084. Okay, then it says 100 out of those 500 leaves are more than 10 centimeters long. More than 10 centimeters. So probability of x being greater than 10, that is 100 over 500. That means x greater than 10, that probability is 0.2. Now, these are two pieces of information that you're given about probability. Now you have to find the mean and the standard deviation. So it's a simple inverse normal problem now. You would make two equations, solve them simultaneously, find the values of mean and sigma. Let's do this quickly. How do you start? You first write it in terms of z. So it becomes probability of z less than some number that equals 0.084. We need to find the corresponding value for z here. If x is 4, what is z going to be? Now, for that, we make a normal distribution curve. This is what it looks like. We first need to figure out if the z value is positive or negative. Okay, so how do you think about this? Area towards left. Less than sign means we're looking at the left side. 0.084, is that more than 0.5 or less than 0.5? This is larger than 0.5. This is bigger than 0.5. Area towards the left side should be more. Sorry, I'm sorry. This is not larger than 0.5. Why did I say larger? This is less than 0.5. This is smaller than 0.5. The area to the left side should be smaller than 0.5. So where do we put Z now? Is it going to be here? Area towards the left side would be larger. That's not what we want. We want the area to the left side be smaller. So that means Z is supposed to be a negative value. This is supposed to be a negative value. Z is negative. All right. And we're given that this area is how much? 0.084. Now, this is not the standard form. We can't use the table for this. Okay. For using the table, we need this form, Z less than a positive number. So what do we do now? We flip this first of all. If we flip this, we say, this is the corresponding positive value of Z. This area is also going to be the same. This is also 0.084. We can't find this area from the table either. So what do we do then? We say, if this is 0.084, the area to the left of this positive value of Z, how much is that going to be? 1 minus 0.084, that is 0.916. So this thing now can be written as probability of Z less than the positive value of Z, that equals 0.916. This is the number that we can find in the table now. Okay. This is the probability. Find the Z value corresponding to this. But then since the actual Z is supposed to be negative, you put a negative sign with that. Let's go to the table. See what the Z value corresponding to this 0.916 probability is there. 0.916. Probability is 0.916. You can say 9160, right? Because probabilities are to 4 decimal places here. 916. This is the smaller number than that. Okay. So what do we take from there? 1.37. So Z is 1.37. This is corresponding to 0.9147. How much do we still need to add? 13. Okay. Go to the right side. Where is 13? We've got 13 here. The third decimal place for Z is going to be 8. So 1.378. That's the Z value. 1.378. Now, this is the positive value of Z that we're getting. The actual Z is supposed to be negative. So we say Z is therefore minus 1.378. That's the actual Z value. Okay. Now you use the formula Z equals X minus mu over sigma. Minus 1.378, that equals X, which is 4, minus mu over sigma. That's one equation. That gives you minus 1.378 sigma equal to 4 minus mu. And you can say mu equals 4 plus 1.378 sigma. That's one equation in terms of mu and sigma. Let's make another one using the other piece of information that we were given. X greater than 10, that was 0.2. Let's write this in terms of Z. First of all, Z greater than some value that is equal to 0.2. Now we need to figure out whether this value is positive or negative, the value of Z. We're looking at the right side now because of the greater than sign. On the right side, the area should be smaller than 0.5. So when you look at the right side in the normal distribution curve, the area should be smaller. Okay, so where do we place Z then? We have to place that on the positive side because only then the area to the right side would be smaller. So Z is supposed to be positive. Let's write that down here. Z is positive. The area to the right of Z is 0.2. Probability 0.2. What about the area to the left of this positive value of Z? That will be 0.8. So we could write that as probability of z less than that value, that is 0.8. This is the standard form now. We can go to the table, find the z value corresponding to this probability, and see what that turns out to be. And z is supposed to be positive here, so whatever is the value you get from the table, that's going to be the z value. Now probability is 0.8 here. 0.8000. Take this number here, that gives you 0.84. 0.84, that is 7995. The difference is 5 at the end. You need to look for 5 on the right side. That's here. It's 2. So z value is 842, 0.842. Okay, let's go back there. Z value is 0.842. Now that you know that this is the z value, use the formula 0.842 equals x, which is 10 in this case, minus mu over sigma. That's another equation that you've got. 0.842 sigma equals 10 minus mu. Mu equals 10 minus 0.842 sigma. Solve these equations simultaneously. You get 4 plus 1.378 sigma equal to 10 minus 0.842 sigma. And you can see what the value of sigma turns out to be from this. What do we get? What's the value of sigma that we get? $2.703. That is what I'm getting on my calculator. 7027, right? So that's 703. You can write that as 70 as well, 3 significant figures, and that's okay. But for finding the mean, you should be using a more accurate number. What's going to be the mean now? Mean is 4 plus 1.378 into 2.703. Ideally, just use the calculator value. And that gives me 7.724, which is just 7.72. That's the mean, and that's the standard deviation. If you want to round it off, you can do that. This becomes 2.70. We've got the values for mean and standard deviation. And that's what we were looking for. Okay, that's the first part. That's just a standard application of inverse normal. Let's look at the second part now. The second part says the lengths in centimeters of the leaves of a different type of tree have this distribution. Now, it's not the same type of tree. The scientist takes a random sample of 800 leaves from this type of tree. Find how many of these leaves the scientist would expect to have lengths in centimeters between mu minus 2 sigma and mu plus 2 sigma. Mean is mu and standard deviation is sigma, right? Remember, this represents variance. The second number written in this rotation, that represents variance. Mean is just mu here. So we need to find how many of these leaves. Okay, so let's find first, so 800 leaves. You're taking a sample of 800 leaves. What's the expected number for the leaves that have lengths between these numbers? Let's find the probability for the length being between these numbers for one leaf, first of all, and then we can multiply that by 800. Let's talk about one leaf for the beginning. What's the probability of the length of one leaf being between mu minus 2 sigma? That's the smaller number, right? That should be on the left side. And mu plus 2 sigma. Now, those of you who understand the definition of z values, understand what z values are. Z values represent the number of standard deviations you're above or below the mean. You might notice you could directly write this as z being between minus 2 and plus 2, right? Because it's 2 standard deviations below the mean. This is 2 standard deviations above the mean. But if not, you can just apply that formula and see what that gives you. Z is going to be between mu minus 2 sigma . This is x, right? minus the mean, which is mu, divided by standard deviation. Mu plus 2 sigma minus the mean divided by standard deviation. What do you get? Mu and mu get cancelled. And mu get cancelled. Minus 2 sigma over sigma, that's minus 2. 2 sigma over 2, that's 2 sigma over sigma, that's 2. You get this thing at the end, right? This is the probability that you want to find out. Probability of z being between minus 2 and plus 2. All right, z being between minus 2 and plus 2. This is what we have to find out. This is simple normal now. Think of the normal distribution curve. It's a symmetric curve, remember? The mean is 0. Minus 2 is on the left side. 2 is on the right side. So the area that you're looking for is this area in the middle of these values, between these two values. This is the area that we are looking for. Right? Now, how do you find this area? Now, since the curve is symmetric, a simple way of doing this would be that you break it down into two parts. You say, let's find this area and then just multiply this by 2. How do you find this area? Finding this is very simple because you can say, find the area to the left of 2. What would that be? That's probability of z less than 2. All of this region. Subtract from that this area. To the left of 0, what's that? That's 0.5 minus 0.5. That will give you this half area. And then you just multiply this whole thing by 2 to get the total region. Right? This should be the quickest. This would be the quickest way of doing this. And now z less than 2, find this probability from the table. This is what we're getting, 0.9772. .9772 minus 0.5, and that should give you the result. You can see what that turns out to be. Okay, what's this? 0.9772 minus 0.5 multiplied by 2, and that's giving me 0.9544. That's the probability of one leaf satisfying this condition, that the length is between mu minus 2 sigma and mu plus 2 sigma. Now, what's the expected number of leaves out of 800 that would be within this interval? You just multiply 800 by this probability, and that will give you the expected number of leaves. That gives you 763.52. Now, since you're talking about number of leaves, that has to be an integer. You have to make sure that you round it off to an integer. We'll say this is 764. That is your final answer. That's the expected number of leaves that you get here. Okay? Makes sense? All right, that's what we were looking for, right? This is the probability that we wanted to find. This is the expected number that we wanted to find.